Alright, so section 8.4, we're going to solve equations. And these are equations that have radicals in them, right? So in order to solve an equation where your variable is underneath or inside your radical sign, you're going to raise both sides of your equation by whatever the index of that radical is. So if it's a square root, you're going to square both sides. If it were a cube root, you're going to cube both sides. Okay, and something to keep in mind is you probably want to isolate the radical before you do any of that. Not that you have to, but it makes it a little easier. Okay, so in this case, I am going to divide through by 2 before I do anything. So I get the square root of 3x minus 15 is equal to 8. And now I can square both sides. And when I do that, I just get the 3x minus 15 without the radical, and I can now solve and get x equals 79 over 3. Now, my little note over here to be sure to check that your answers are valid means that when you get an answer, make sure that when you plug it in, you're not getting a negative underneath the radical sign, or when you plug it into the actual equation, it actually does work out. Okay, so just do a mental check. You don't have to write it all out, but just think about, does this seem valid or not? Here's another example. If we have two radicals that are added or subtracted from each other, and you need to solve it, you're going to still raise both sides of the equation by whatever the power is going to be, but you have to think of it as this entire side, not each thing individually. However, in this case, because both of these are subtracted and equal 0, what can actually be easier is if we move one of these over to the other side, and then when you square both sides, the radicals simply disappear, and you're just left with the 2x minus 3 is equal to 5x minus 21. And that should make sense, because if these are going to subtract to be 0, that means that they have to be identical underneath the radical sign. So that only happens when x is equal to 6. Okay, so we like it when those problems come up. However, we do have problems like this, where it's not equal to 0, not even the subtraction one. And you do have to consider taking this whole quantity here and raising that whole quantity to a power of 2, and then raising the 6 to a power of 2. Now, because these are both radicals, and you have a binomial looking thing raised to a power of 2, you'd have to FOIL that out. You can imagine how difficult or tedious that could be. So what could be potentially easier is if we move one of these radicals to the other side with the 6. We still have to take the whole quantity and raise it to the power of 2, but it makes working it out a little bit simpler. So that's what I'm going to do. I move the radical 5x minus 4 to the other side, and now I am going to raise both sides, the entire quantity of both sides, to the power of 2. And that's why I put parentheses around this, because I need to think of this as something that I would FOIL to get. I can't just square this and square that. It'd be lovely if we could, but not so much. Okay, so now simplifying. When I square the square root, the radical goes away. Here, when I multiply all of this out, you get 6 squared minus 2 times 6 times this, which gives you the negative 12 radical 5x minus 4. And then when you square this, you get positive 5x minus 4. Well, what happened was we got rid of the radical on this side, but there's still a radical over here. So we're going to simplify this equation as much as we possibly can by combining like terms and dividing through by negative 3 until we get it as simple as we possibly can, where you have a radical on one side. And now I am going to square both sides again. So I get x minus 11 quantity squared, and then this whole thing quantity squared. So x minus 11 quantity squared, you can just multiply that out. And then this, you have to remember to take the 4 and square it. That's the 16. And then the radical, when you square it, gets rid of the radical sign. Okay, so now I'm going to distribute my 16 through and combine like terms, and you end up getting a quadratic equation. And no, you can't factor it nicely. It would be lovely if we could, but you can't, so we won't. But that doesn't mean we can't solve it. We're going to go ahead and use the quadratic formula. And there's all the work for the quadratic formula. And when you get right down to it, this right here is your answer. And you would have to check to make sure that when you subtract, if you get a negative when you plug it in, does it make sense? And luckily, when you subtract the 29 minus 4 root 41, it's a positive 3 point something or other. So it will work when you plug it in. If you don't believe me, you can go ahead and try it out yourself. Okay, so hopefully you guys don't have too many of these really, really long problems, but as you can see, they are still doable. All right, so have fun with that.